Hi, folks. Howdy, Yalla. It's Shalom Chaverim. It's wonderful to be here in this beautiful country. Thank you so much to the JFrog team for making this happen. My name is Dex. I don't have an intro slide, but I work at a company called Replicated. I am working solutions engineering and customer success, which essentially amounts to I get paid to have bad opinions about Kubernetes. And I'd like to share some of them with you today. And more so, I have a puzzle that I've been working on. Who here likes puzzles? Solving puzzles? Okay. Atem be'emet metatnetim. Close. Ani medaber katzat. Cool. So I got a short agenda. We'll just jump right into it. I want to start by defining what we mean by off-the-shelf tools, especially in a cloud-native world. And we'll start by talking about the 4 categories of delivery. So the first question is, whose code are we talking about, and whose servers, whose infrastructure? And I'll venture if you're here to do DevOps, 90% of you are delivering your own code to your own servers. It was written internally, it gets deployed internally. So you're up here, you're doing this. And on this grid, put another way, you're in this corner. But if you deploy any off-the-shelf tools, either commercial or open source, Thanos, Prometheus, all sorts of stuff. This is not exhaustive. We all know how big the map is, and this is like from a year ago, so it's even bigger now. But if you're running any of these things, then you're over here, in this corner. You're deploying someone else's code to your own servers. And if you work on these projects, then your code is going out to someone else's servers, and you're up here. We call these the off-the-shelf use cases, OTS. And this is what we're going to focus on today. So specifically, how are they different from the first-party cases, and when something goes wrong, and when we need to diagnose and fix problems. So why are we making this distinction? In the first-party world, as a maintainer, I have direct access to the infrastructure. I can get in, I can maybe SSH even, and I have a well-known monitoring stack. I can quickly go and look at my Grafana dashboards, my Splunk queries, whatever I have. And every time something goes wrong, this is getting deeper and deeper. And so in minutes, in seconds, I can look somewhere and get a deep understanding of the system. Not true if it's off the shelf, because it's not my app. I didn't write it. I don't know the architecture. How often do you know which logs to query? How often have you queried the logs for 1, 2, 3, 4, 5 different processes, only to find that the useful error was in the 6th process? And the exception is maybe really well-known things, like Postgres. You may have a DBA who actually knows Postgres really, really well. But if you're at a big company and you're running Postgres and Jenkins and Jira and perhaps JFrog, you're not going to be an expert in all of these. So what do? And from the maintainer side, you can't just SSH into the infrastructure and try it out. You can imagine trying to stand up Kafka in your infrastructure. You're not going to go on the GitHub repo and say, hey, I'm having this issue, here's my problem. Why don't you give me your public key, and I'll give you a VPN config you can SSH into my production network, and tell me what's wrong with it. And the other thing, too, is there's lots of different observability stacks that you might want to integrate with. I mean, we have a ton of things just, again, on the CNCF landscape. Can you imagine building an open source database that works with every single combination of every technology on here? Even if you just picked one from each of monitoring, logging, tracing, that's 12,000 different stacks that you might have to support. And this extends beyond monitoring, just to DevOps in general. You remember a long time ago we had the wall and Dev throwing it over to Ops. People call this the chasm of sorrow sometimes. But then we brought in DevOps and we fixed it. And now everyone's happy, everyone's working together. We got devs managing infrastructure, we got operators writing code. We're one big happy DevOps family, right? This is harder for off-the-shelf, because I can't just go tap someone on the shoulder and get help with something. And I can't, even if your company, Acme Big Corp, is doing DevOps and super good tools, they're doing DevOps too. If I want to take something from super good tools and run it in my data center, we're back to this. And by the way, it's a data center, maybe my AWS cloud, my Azure, or maybe a real bare metal vSphere. So there's a few options to make things better here. You're probably done at least a few of these. Most of you have probably done all 3 of these in one way or another. So we'll talk about the brute force method, the open standards method, and then sort of a pragmatic minimalist approach that I want to dig a little deeper into. A couple ground rules here. No sending data outside of the off-the-shelf consumer's data center. We want this to work in super secure environments that maybe even totally air-gapped. There's no outbound connection at all. Number 2, maintainer won't have access to log into the consumer's data center and debug things or make changes or manage the application. Because I think if you're going to trust someone with SSH keys or kube control into your cluster, you might as well send it to them and let them run it for you. And then we want to minimize as much as possible the need for a consumer to understand the application that they didn't write, they don't own, they don't maintain. So this first brute force method, you've probably seen this as a couple examples, but this is send the whole monitoring stack in with the application. So you could imagine shipping an appliance or even a Kubernetes application that comes with its own Grafana dashboards, its own Prometheus, and maybe even a Loki stack to do log aggregation. And then you go and plug that whole thing into someone else's infrastructure. This is cool because there's no configuration. You get a lot of visibility right out of the box. As a maintainer, I have the same stack everywhere. If I'm trying to diagnose a problem, I say, go to this dashboard, tell me what you see. And it evolves with the application. Because the whole monitoring configuration is baked into the app, every time we diagnose an issue in the field, we get to learn from it, and everybody benefits. Now, on the downside, there's a bigger footprint, right? You're shipping an entire monitoring stack, and heaven forbid you're also doing a Thanos M3 giant scale thing. It gets big. It also leads to what we call the 10 Prometheuses problem, where if every application does this, you have 10 separate little Prometheuses, you have no single pane of glass, and you have a bunch of overhead that's probably not necessary. The second one I want to talk about is open standards. So this is you build adapters for different observability stacks, and you say, hey, if you have Prometheus, here's where you scrape. You say, hey, if you have statsd, give me an endpoint, and we'll push it through into your pipeline. This one kind of falls apart, because what if they're an elk shock? I don't know. I got to either build an adapter, or they got to build an adapter. So the good here is it's a small footprint. And because it integrates into the consumers, your existing monitoring pipeline, you get to you get that single pane of glass. You get to see everything in one place, because all these systems, the ones you write, the ones you pull in from outside, they're all connected. They're all talking to each other. And so if you have to go from dashboard to dashboard to dashboard to see them, it gets difficult. And the bad side, as a maintainer, I got to learn to support every single monitoring stack out there. We saw there's 12,000 different combinations just on the CNCF tiles. And as a consumer, if I don't use that, if I'm a Zabbix Nagio shop, then I don't get to take advantage of any observability. I kind of am on my own here. Some examples here are, there are examples. You guys have seen them. The third one is the fun one. It's kind of the quick and dirty method, the pragmatic approach. And it basically accounts to a run book with some manual commands. You say, hey, it's not working, send me, you can see this in a lot of GitHub repos. They say, hey, if you're submitting an issue with the app, send us these pod logs, and exec into here and get this file, and submit it with your bug request. That's kind of the run book-based approach. You're kind of just gluing it together with bash or with run books, and you're throwing people at the problem. And this is kind of cool, though. This works everywhere, and honestly, when the other two break down, this is usually what you're going to end up doing. If Grafana is down, you're back to checking logs manually. It works anywhere. There's no agent or stack or daemon to install, and it's totally decoupled from the application. But on the other side, again, it's manual, so it's error-prone. I don't know if y'all have been doing this for 20 years, but I remember maintaining a big pile of bash scripts, and I have not been doing this for 20 years, so I don't know anyone who enjoys the idea of, oh, let's just ship more bash scripts with the application. It's a bit of a leaky abstraction, too. If they're running a lot of kube control commands, at a certain point, you're having the consumer ends up learning about the application architecture. We said we wanted to minimize that. And it's procedural. It's not declarative. This is the cloud-native world. We want desired state and declarative specs. We don't want a bunch of scripts. That's the idea. So this is, if you run sysdig cloud in your Kubernetes cluster, this is from one of their open source repos. They have a script called git support bundle. It's a lot of bash, but it goes into every pod and gets a bunch of files. It runs a bunch of commands, puts them all in a tar gz, and then you can take that and send it to the maintainer team. This is another one, kind of similar. This is from the JFrog docs. It says, hey, if you see this error in this log file, here's the problem, here's how you fix it. It's the runbook approach. And in reality of these three, you probably want to blend. Raise your hand if you've deployed or built an app that does number one. Couple. What about number two? Pull something in and integrate it into your stack? Okay, I better see a lot of hands for number three. Who's running manual log queries to try to fix things? Yeah. It's the least exciting one, but today I'm going to show you how to do it really, really well and hopefully make it a little more exciting. And it's going to use an open source framework that we created at Replicated called troubleshoot.sh. It's a Kubernetes native system, and this is all Kubernetes specific, but again, these concepts apply to whatever infrastructure you're deploying to. So imagine you're an operator and you want to deploy, let's say, for example, Artifactory OSS. First step, you're going to read the docs, you're going to check the prerequisites, and you're going to see, okay, I need this much memory, I need this much CPU, and I need this, and this storage class or something. I'm going to run some manual commands, I'm going to check the cluster, I'm going to say, okay, good, it has enough available memory, I got enough nodes, et cetera, et cetera. You deploy it. Oh, it's crash looping, the pods are broken. And so what do? You start doing git pods, you start looking at logs, and you start checking around and poking around. And eventually, maybe you find an error, and then you fix it. And you do that over and over and over again. And the idea is that troubleshoot.sh is a tool that's going to get us faster and faster to identify what's going wrong, select a remediation step, and execute that, and then repeat it. And again, we can do this easily when we wrote it, and we run the dashboards, and it's first party, but when it's someone else's code, there's a different set of tools we're going to use. So this is cool. I'm not saying it's perfect, and we'll see what's still wrong with it on the other slide, but it's no longer a manual. It's easy to maintain because it's just a YAML file you write, and we'll look at that. We can do this without the consumer needing to learn about the application itself, and it's no longer procedural. Still no single pane of glass, still just a point-in-time snapshot of what is happening. And for now, it's Kubernetes only with a little bit of an asterisk on there that we can get into. There are trade-offs, but being pragmatic means making the right trade-offs and deciding. Again, the answer is you'll probably use a mix of all three. But this is super, super valuable. We've seen people cut escalation rates by 50 to 60%, time to recovery by 30, 40, 50%. And so basically, we're going to codify our runbook as a YAML file, and we can pre-flight check everything from the Kubernetes version to the distribution to cluster resources to network properties. And then after we've deployed, there's a support bundle feature which can pull logs and run analysis and look at either via regex of plain text or JSON query on Kubernetes data, show you what it is. So real quick, I have, for this demo, I got a workstation over here. We have a Postgres running, and then we're going to deploy the Artifactory Helm chart and point it at our Postgres. The Postgres could be anything. It could be RDS or whatever. It's just a thing that is outside of the chart itself. And then we're going to add to the repo this preflight.yaml and a supportbundle.yaml. And those are going to talk to the Kubernetes API server via our kubectl plugins, and they're going to tell us what we did wrong, hopefully, if we did it right. So we'll switch over to the demo. Okay. And let's get to it. So I've got a little 2-node Kubernetes cluster here. There we go. I did already deploy a Postgres server here. Let's see. Can do giant clusters, but I still can't use a clipboard. Let's see. Okay, cool. So we're just deploying a single node Postgres. You can see I'm just hard coding the password to Yala user and howdy Yala. And we can have a look at the pods. It's up and running. And just to be extra sure, again, I have a port forward on here. Oh, or I do not. Pay no attention to the man behind the curtain. As I said, I have a Postgres server running here. Hey, that looks like Postgres, right? We can check the version. Great. Cool, we're in. So what we're going to deploy here is a few things. So this is the Artifactory OSS chart. I added just a couple files in here. So this is what we're deploying. We're looking at the have Helm values built in for different sizes, small, medium, large. We can make it a little bit bigger. We're just going to deploy a medium-sized instance, but again, there's recommended limits, requests, Java ops for all these sizes. So we translated these into troubleshoot pre-flight YAMLs. So this is going to check kind of memory allocatable in the cluster. So this is not just the number of nodes or the total amount of memory, but we're going to actually query across all the nodes in the cluster, how much memory are they reporting? We aggregate it, we make sure there's enough there. It's kind of a simple example. There's a lot you can do here, but we'll jump through. So I'm actually going to point it at this raw file. You can point it at a local file, or it's something that you host anywhere. And we're going to run some pre-flight checks. So again, these are just kube control plugins. They're in the crew index. Get them anywhere you get your kube control plugins. There's a couple warnings here. Ignore those. It's a GKE thing. Cool, so the cluster memory is good, but it says, oh, we're going to recommend a 6 allocatable cluster CPUs. So I am the admin now. Instead of trying to deploy it and then realize I'm under-resourced, I'm just going to make my cluster bigger. And while that is happening, just a GKE cluster, we can look at a couple things in here. So what we're specifically doing is this node resources check, but there are a ton of things that you can check with this. You can check memory capacity. You can check the number of nodes. There's everything from checking the status of deployments, HTTP requests. You can do you can actually just run a pod. So any custom check that you want to run in the cluster to validate the environment before the app is deployed, you can package it in and run it, and this kind of supports a full pod spec. So it's still growing. What's the one? You can look at HTTP requests. So this is another cool one. So if you want to ping an endpoint, and again, the pre-flight and the support specs are the same kind of format. So whether you want to hit a metrics endpoint on a service that's running and scrape metrics from it, or whether you want to make an outbound request and make sure that the app is going to, from within the cluster, the networking is set up that it'll be able to make a query out or talk to a database or whatever, it's possible. Cool, so we have our bigger set of nodes now. I'll run the pre-flight checks again. More warnings. And we'll see everything is green now. And this also has a cool, I'll run it with the large spec. There's a cool JSON interface to this too. So you can run this in scripts and automation and CI/CD and things like that. So this one is warning because the large one needs 8 CPUs and we don't have that. So I have a values YAML file that I'm just going to use to deploy. We're just pointing it at our external Postgres server. And I'm going to do the Helm install. This thing takes about 90 seconds to come up, so I actually already installed it, but this is what I did right before. Okay, cool. So we just deployed Artifactory OSS. Let's see if it's running. Oh, there's no pods. Oh, because I forgot the namespace. Okay. Let's see. Let's try that again. Okay. It's running, but it's not ready yet. Let's see. Let's check the logs here, folks. Oh, it's not. It's what? Oh, right. I forget. Namespace. Okay. Here we go. I found it. Okay. And then we're scrolling and we're reading, and I love reading Tomcat. Who here loves reading Tomcat logs? No? Okay. I found it. Oh, it's a big stack trace. There's an error. Is that it? Let's go to the top. Could not initialize database. Password authentic. I got the wrong password. Who would have thought? You know, they told me, I said I was going to try to deploy Artifactory. And the JFrog folks, they say, oh, it's not going to work. I'm like, oh, we'll get it working. So if you're really smart, maybe you've done this before, you run a query, and maybe you have a big grep, and you know what the logs look like. And it's, let's see. There we go. Okay, so we find the error, we use grep, and so we're not skimming through all the logs because we kind of know what we're looking for. I don't know if anyone was timing that. I didn't look at the clock, but it takes a couple of minutes to figure out what the problem is. So instead, what I'm going to do is I'm going to open up this support bundle file, which again is just a declarative spec that says what to collect and what to analyze and what log lines to look for, and we're gonna pull this in. So this is grabbing logs, it's grabbing status of deployments and statuses of stateful sets and everything in there. It's going to print a bunch of warnings, but then we should get a UI. And ideally, instead of checking a bunch of pods and forgetting what namespace and et cetera, we know, okay, we have the memory is okay, CPU is okay, Artifactory is not running. That's cool. Nginx is also down. The database was connected, but there's a problem with the credentials. So instead of checking 10, 5, 20 commands, we have a declarative spec that tells us how to do it. And I suppose that I have a new set of values that fixes the password. I had dashes instead of underscores. And then we'll do this Helm upgrade. We have the new one. Call the pod, and we'll come back to it. And hopefully that'll be working. And maybe, if we're lucky, soon. Give it time. But I think now we can probably run another support bundle. And we'll also look at what's inside this. So assuming this comes up and it's all green, you may still end up with some issues. Okay, cool. So here we couldn't even get the file. But what you can see in here is actually what's in the file. We have the logs for every container, including the init containers. We have deployments and stateful sets in the whole cluster. And we can actually just pull the logs this way. So I can see, okay, here's the generation, here's the replicas. We could do it with JQ. So it's a lot. All that information is just pulled into a tarball. And so if I have trouble figuring all this out, I can bundle it all up and send it out. But the idea is, again, we're going to figure out what's wrong. We're going to figure out what steps to take, and we are going to fix it. And let's see if we've got... Yeah, I think it takes 30, 90, 60 seconds to come up. I don't know. Y'all have done this more than I have. Let's see. We were supposed to fix it. Let's see. All right, it comes up eventually. Let's pop back to the slides. Cool. So, that's the video, in case it broke. That's okay. So if you run off-the-shelf software, what can I do? Think about which of these three models you're currently supporting. And what I really want to get at is how can we apply DevOps principles to this off-the-shelf world? How can you think about change fail rates? How can you think about time to recovery? How can you think about lead time and batch size? I mean, with a tool like this, our goal is really that you, because it's easier and easier to operate off-the-shelf software, you can deploy Grafana and Thanos and upgrade all of your off-the-shelf stuff 5 times a day, the same way you're doing this with all the stuff that you write internally, right? You're doing 10 deployments a day of your own stuff, but your Redis is sitting there, you haven't touched it in a year, because it's scary. But if we can bring observability and DevOps to this off-the-shelf world, I think it makes everybody's life better. You can try out troubleshoot.sh. If you write a spec for an open source project, you can contribute it back to the maintainer. And if you build off-the-shelf software, again, think about which models you're using. Apply DevOps to how you ship into other people's data centers, and give this a shot. We'll be hanging out at the booth. Would love to chat more. You can host your spec at a URL somewhere. Doesn't have to be in GitHub or in a repo. And just remember, folks, like we're here in person, DevOps in person, because DevOps is people. And especially if you're involved on kind of the commercial side of off-the-shelf stuff, there's a lot of people that makes this work. Customer success engineers, solutions architects, sales engineers, community managers, developer advocates. There's a whole lot of people who, if you are somebody who's in the field, getting hands-on, helping people get stuff stood up and running, then you should be thinking about this. If you are someone whose job gets better and more efficient and more fun when you're not spending all day just trying to get the thing working in someone's environment and you can actually get to value, then you should be thinking about this. I really think that, and we really think at Replicated, that off-the-shelf software is the final frontier for DevOps. It's kind of been left behind. It's still the Wild West out there. And it's kind of a topic for another talk, but at Replicated, we're building this idea of not site reliability engineering, but field reliability engineering. How do we take DevOps and apply it to this off-the-shelf world? I think that's it. Come say hi. We're in the Kubernetes Slack. There's a repo, a link to the sources for all this stuff. Go look at Replicated. We're doing a hands-on lab at Microsoft Reactor next week on Monday. Come hit us up. We're going to deploy Kubernetes clusters into air-gapped environments. And thank you all for coming, bringing your energy.